Okay, how is everybody doing? This is take 3 of this video. I had a screaming little girl asking for chocolate milk, so let's hope that this works out a little better. Hope you understood the basics of covalent bonding that today's, or yesterday's, I should say, video explained. Um, Today we're going to kind of combine that together a little bit with some information we learned in the past, which is Lewis dot structures, and try to put them both together. So it's a pretty easy lesson, very short presentation, and we'll do some practice today too. So um, let's get to it. Let's get to the PowerPoint presentation, and let's see how this works. So we know how to do Lewis dot structures already, at least you should. If you remember, a Lewis dot structure in the past has been an element that you draw dots around that represent the valence electrons, and the maximum amount of dots you can draw is 8. Meaning it's a full octet, like the noble gases have that. You can do the same thing with covalent compounds. So since covalent compounds share their electrons, remember they're nonmetals. They both the nonmetals in the compound, they both want those electrons. So what they do is they both take those electrons and they share them. We call them molecules, and we can basically predict how these electrons are going to be shared based on certain characteristics. So remember the octet rule. The octet rule that has to have 8 valence electrons to be stable. But remember, hydrogen only needs 2. We call that a duet. So hydrogen is going to be kind of the exception to this rule. It only needs 2 valence electrons to be full. So that fills its outer shell. Remember the S sublevel. All other nonmetals, so everything but hydrogen, needs enough electrons to form an octet, which is exactly 8 valence electrons in their outer shell. That's our goal. If it's hydrogen, 2 valence electrons. If it's anything else that's a nonmetal, and that's all we're dealing with, it has to have 8. Let's do an example. These are very simple examples. Hopefully, prove the point pretty easily. So a Lewis dot structure for an example like that's hydrochloric acid, HCl, between hydrogen and chlorine. So hydrogen, first column, has 1 valence electron. Chlorine, a halogen, has 7 valence electrons. So both of them are not, stable. Hydrogen does not have a duet. Chlorine does not have an octet. So what can we do? Well, we can draw their. First, we would just draw their. This is a simplified way of doing this. There'll be a much more complex way of doing it later on. But if we just draw the Lewis dot structures of these elements, hydrogen with, as you can see, with 1 valence electron, and chlorine with 7 valence electrons. This one is basically all alone by itself. And all that really has to happen is, it's kind of a logical thing, if this compound comes together and starts sharing these 2 electrons, so this hydrogen shares its red electron with the green one here from the chlorine, and vice versa, that shared pair, as we found out yesterday, is called a covalent bond, a single covalent bond. And we could represent it just like that. In actuality, we're going to draw it sort of more like with a line between it, but let's go over this first. There's the octet, and here's the duet. So that's good. Hydrogen has to have the duet, 2 electrons, 1 shared, 1 its own, and chlorine with 7 of its own and 1 shared. This is how we actually will draw it usually. Instead, you can draw the 2 dots in between, but a lot of times you just draw that line, and then you draw all the extra ones that chlorine has. These are not bonding. These are not involved in the bond at all, but they are pairs of electrons. So that is the Lewis dot structure for hydrochloric acid, HCl. Pretty easy so far. Let's do some other examples. Here's water, obviously a very common one. Water has 1 valence electron, just like before. And oxygen in the 16th column has 6 valence electrons around it. So if we draw the 2 H's and the 1 O, the 2 H's both have 1 dot. The O has 6 dots. When you draw them around, 2 of them are paired up nicely. Then there's these here, kind of want to have a partner. So one of the H's is going to go here. One of the H's is going to go here. And we can kind of do that just like that. And all of a sudden, we have the Lewis dot structure for water, H2O. There's the octet for oxygen, has 6 green ones from its own collection of valence electrons. And then the red ones are the ones it's sharing, so 2 single covalent bonds with those hydrogens. So there's a duet for hydrogen and a duet for for this hydrogen too. So the hydrogens are good to go. They're stable, and so is the oxygen. So there's your Lewis dot structure. I kind of like drawing with the lines here instead to represent the two shared pairs of electrons. That would be what your Lewis dot structure would look like for the compound we know, or molecule we know as water, H2O. And finally, NH3, commonly called ammonia. NH3 has one single nitrogen and 3 hydrogen atoms. So hydrogen still has 1 valence electron, and nitrogen, being the 15th column, has 5 valence electrons. So I think you see where this is going, hopefully. There's our 3 H's with a single valence electron, and here's nitrogen with its 5 valence electrons, and only one of them is paired up. So these are looking for a bond, basically. They're looking for to do something else. And luckily, if there's 3 H's around, they will share those electrons with it and basically form this structure right here, where you have an H bond there, or an H and nitrogen bond there, a covalent bond there, a covalent bond there, and a covalent bond there. So 3 single covalent bonds. The nitrogen has its octet, and the 3 H's all have their duet. They're good to go. They're happy. This is what the structure would look like if you draw the lines, kind of more streamlined version, and that's what you want. So those examples are pretty easy, I think. I really do think this is a concept that most of you will get right away. If not, rewatch it. We're going to get some practice, ask some questions, and hopefully this is pretty well understood. So I'm going to sign off on this presentation here, and hopefully you'll get some practice with a worksheet very soon. So signing off right now. Have a great day. Thanks.